Morning all of you. The next problem which we are going to do is based on design of Chebyshev filter using impulse invariant method. So here the given problem is 0.707 less than or equal to modulus of h of e power j omega less than or equal to 1, where omega varies between 0 to pi by 2, and less than or equal to modulus of h of e power j omega less than or equal to 0.2, where omega varies between 3 pi by 4 to pi. In that, the given problem A1 is 0.707, which is nothing but the pass band gain, A2 is 0.2, which is nothing but the stop band gain, and omega 1 is pi by 2, omega 2 is 3 pi by 4. So we have the step of design procedure. The first step is to find out omega 2 by omega 1, which is equivalent to, so omega 2 by omega 1, which is equivalent to 3 pi by 4 divided by pi by 2. So when you substitute this and find out the value, it is 1.5. The next step is we have to calculate the epsilon, which is 1 by a1 squared minus 1 the whole power 1 by 2. So if you substitute the a1 value here in this formula, you will be getting the epsilon value as 1. The next step is n, to calculate the order of the filter n. So n equal to cos h inverse of 1 by epsilon 1 by a2 squared minus 1 the whole power 1 by 2 divided by cos h inverse of omega 2 by omega 1. So in this, when you substitute the epsilon value and a2 value here, and then after substituting omega 2 by omega 1 value, which we have obtained as 1.2 in this formula, so we will be getting n value as 3.3, which is approximately equivalent to 4. So in order to find out the cos h inverse, first calculate the inner that is parameter values. Then in the calculator press shift to cos hyperbolic function. You can get the cos h inverse of this value. If you give, you will get the value for it. Then the next step is to calculate the analog cutoff frequency. The formula is omega 1 by t divided by 1 by a1 squared minus 1 the whole power 1 by 2n. So when you substitute the value for omega 1 and then a1 value and n value, you can able to get 1.57 as the analog cutoff frequency. Here we will be assuming t equal to 1 second. So now the order of the filter is 4. Then we have to choose the transfer function h of s equal to the product of k equal to 1 to n by 2 bk omega c square divided by s square plus bk omega cs plus ck omega c square. So in this we have to substitute n equal to 4. So it will be k equal to 1 to 2. Then bk omega c is 1.57 squared whole squared divided by s square plus bk 1.57s plus ck 1.57 the whole squared. So in this, when you substitute the k value, it will be first k equal to 1 and k equal to 2. For k equal to 1, it is b1 2.464 divided by s square plus b1 1.57s plus c1 2.464 into substitute k equal to 2, b2 into 2.464 divided by s squared plus b2 1.57s plus c2 2.464. So in this, we have to find out the b1 b2 value and small b1 small c1 small b2 and small c2 value. So in order if you find out the small b1 value, so first we have to assume C naught equal to yn, and the Ck is C1, which is given by the formula yn square plus cos square of 2k minus 1 into pi divided by 2n. So in that you find out the C1 and C2 value, which is 0.907, 901 and C2 is 0.194. Then B1 and B2 value after substitute yn, after you find, if you find out the yn value is 0.22, then in the formula when you substitute you will be getting B1 as 0.16, B2 as 0.40. Then after substituting all these values here, you will be getting the simplified transfer function as h of s equal to 2.464 B1 divided by s square plus 0.5256 0.25 into s plus 2.22 into 2.464 into B2 divided by s square plus 0.628 into s plus 0.47. Now the order of the filter is n equal to 4. So that's in order to find out the B1 and B2 value, you have to use substitute s equal to 0 in the h of s. It will be ha of 0 and equated to 1 by 1 plus epsilon square whole power 1 by 2. So in this, when you substitute the s equal to 0 in this expression and equated to 1 by 1 plus epsilon square whole power 1 by 2, we know that epsilon equal to 1, and then you will be getting b1 equal to b2 equal to 0.121. Then we will be substituting the b1 b2 value here in that formula. So you will be getting the expression as 0.08 divided by s squared plus 0.25s plus 2.22 into s squared plus 0.628s plus 0.47. Now we have to apply partial fraction, find out the value of a, b, c and d. Then only you can able to apply the inverse Laplace transform. Now, if you apply partial fraction, it is as plus b divided by s square plus 0.25s plus 2.22 plus cs plus d divided by s square plus 0.628s plus 0.47. Now, in this, when you substitute the value, that is yes, when you substitute, that is take the LCM of it and then find out the value for collecting the coefficient of s squared, x cube, s square and s, you will be getting a quadratic equations. So we need to solve this particular equation to find out the value of a, b, c and d. So we know that a equal to minus c, then we have to find out b, c, d. So if you solve this particular equation, so you will be getting the value for you can substitute in these values. Then you can apply the inverse Laplace transform, sampling and Z transform to obtain the h of z.